Now let's explore some of the body cavities and the membranes that line them. There are two major dorsal cavities and two major ventral cavities. The dorsal cavities are the cranial cavity and the vertebral canal. Each of these are lined with meninges. The ventral body cavities, those below the spinal cord, are the thoracic cavity and then the abdominal pelvic cavity. The abdominal pelvic cavity is one big cavity that's divided by the pelvic floor muscles into the abdominal cavity and the pelvic cavity. Each of these cavities are lined with serous membranes and filled with viscera or organs. This image will help us understand how each of these membranes work. Now basically, there are these different cavities throughout the body. And imagine that you had an empty container like this outlined in yellow, and in it you had a balloon that was lightly filled with air. And if you were to plunge something down into the balloon, maybe it's just your fist, but here we're showing lungs being pushed down in through the top of the balloon here. Now the lungs are covered by a layer of balloon, and they're pressing another layer of balloon up against the outside of the space that's outlined in yellow. So now we have two layers of membrane, one layer over the organ itself, or the visceral organ, and another layer around the outside, around the perimeter. So we'll have these membranes being called visceral serous membranes, the one that wraps the viscera, and parietal, ones that are in the perimeter, parietal serous membranes, wrapping the outer edge of the cavity. In between these membranes, we'll have serous fluid. And the whole point of this membrane-wrapped viscera and membrane-lined container is to allow slippage of the organs, to reduce friction so that the organs can move around freely inside of our bodies. So let's begin by looking at the cranial and vertebral canal. We'll look at these in much more detail later in this semester, but in basic, the cranial cavity contains the brain and it's lined with meninges. We'll look at the details of these meningeal linings later. The vertebral canal encases the spinal cord, and the spinal cord and the canal are also lined with meninges, which we'll address later. The thoracic cavity is composed of three different regions: the mediastinum, and then the pericardium, and the pleura. The mediastinum contains the heart, some major blood vessels, the esophagus, the trachea, and the thymus, and it's an independent section wrapped in membranes from anything else in this cavity. The heart, inside the mediastinum, has its own membranes. It has the visceral pericardium, that's the membranous layer that's tightly bound around the heart. The parietal pericardium, which is a layer outside of the heart that lines the cavity the heart sits in. The cavity that the heart sits in is the pericardial cavity, and it's filled with pericardial fluid. There are also membranes around the lungs. The visceral pleura are the membranes that are stuck tightly to the lungs themselves. The parietal pleura are the membranes that line the perimeter of the cavity within which the lung sits. So let's take a closer look at the pericardial membranes. Here you can see the heart, and the purple layer around the outside of the heart is going to be the visceral pericardium. Remember the balloon example? The heart, imagine like a fist being pushed down into that balloon and creating a double layer. This double layer comes back and wraps around, and then it's going to form the pericardial cavity. This is the parietal pericardium, the layer that you see right here. So now we have this double membrane wrapped organ. Inside the pericardial cavity, we'll see pericardial fluid. And now a closer look at the pleural membranes. You can see as if the lung here was pushed into that double-layered balloon. The purple layer on the inside is the visceral pleura, and that would be continuous here with the parietal pleura that creates the lining of the cavity within which the lungs sit. In the pleural cavity, we'll see pleural fluid. Again, the same substance that we'll see surrounding the heart in the pericardial cavity. Now looking at the abdominopelvic cavity in more detail. The pelvic brim is going to separate the abdominal and the pelvic cavities. The abdominal cavity contains most of the digestive organs, the kidneys, and the ureters, whereas the pelvic cavity contains the reproductive organs, the rectum and the urinary bladder, as well as the urethra. The peritoneum is the serous membrane of the abdominopelvic cavity. There is a visceral peritoneum that wraps each of the organs, and then a parietal peritoneum that lines the whole cavity. This peritoneal cavity, the space that's between the organs and the boundary of the container, is filled with peritoneal fluid. Some organs are retroperitoneal, behind the peritoneal lining, and some organs are intraperitoneal. Now, the viscera that we've been referring to would be things like the intestines that are entirely wrapped in visceral peritoneum. You can see, though, the peritoneal layer comes here around the back side of the cavity, and some organs are actually behind the parietal peritoneum. And some organs are partially wrapped in peritoneum, and some organs are all the way wrapped. Those that are behind are called retroperitoneal. They're behind the times. Those that are enveloped in peritoneum have a visceral peritoneal layer, and they are called intraperitoneal. So you can see that the organs are either all the way pushed into the balloon or partway pushed into the balloon. Sometimes they're so far pushed into the balloon that the balloon seals behind them. This would form the dorsal mesentery. The dorsal mesentery is going to suspend things like the intestines from the posterior abdominal wall. The ventral mesentery is going to suspend viscera from the anterior abdominal wall in a similar way. These are divided into the greater omentum and lesser omentum. The term serosa refers to the outer layer of an organ that's formed when the visceral peritoneum divides and wraps around the organ. This figure might illustrate that well. So you'll see lots of bands of small intestine here. These small intestine are wrapped in serosa or serous layers. They have a visceral peritoneum. Here, around the outside edge of the cavity, you can see the parietal peritoneum. And then the space in between, which actually isn't very much space at all once you fill up the area, is called the peritoneal cavity. The peritoneal cavity isn't really a space at all. It's just a potential space. It's the space that's found between two membranes that are normally pressed firmly together. They're not physically attached to each other, and they could separate. They could fill with fluid in unusual situations. We'll investigate some of those later in this course. Examples of these potential spaces are the pleural cavity. Air or fluid could accumulate between the parietal and visceral pleura. That is, between the membrane that surrounds the lung and the membrane that lines the cavity that the lung is in. And this could form a space. This would be called a pneumothorax. It's not a good situation. The uterus is another great example of potential space. The non-pregnant uterus, the mucous membranes of the walls are actually in contact. However, when a baby begins to grow, an implant inside the uterus, that potential space opens up. Okay, time to close your book and notes again. See what you can do to diagram each of these cavities and name the membranous linings of each. Again, do what you can without cheating, and then go ahead and cheat. Fill in the details. Now we'll move on to a quick survey of the organ systems. There are 11 organ systems that we'll explore throughout the next 2 semesters. There are 3 involved in protection, support, and movement. Those are the integumentary, skeletal, and muscular systems. There are 2 involved in internal communications and integration. Those are the nervous system and the endocrine system. There are 2 involved in fluid transport, the circulatory system and lymphatic system. And then the immune system takes care of all the defense. And then input and output systems, the respiratory system, the urinary system, and the digestive system. And finally, the reproductive system takes care of all of our reproduction. We're going to investigate each of these systems one by one as we move through the next 2 semesters. This semester, we'll explore the integumentary system, the skeletal system, the muscular system, and the nervous system and endocrine systems. In the following semester, we'll explore the lymphatic system, the respiratory system, the urinary system, and the digestive and circulatory and reproductive systems. So now that you've completed Chapter 1 and AtlasAii, you might spend some time exploring the various pictures in the end of AtlasAii, looking at an overview of some of the systems that we'll investigate throughout the semester. Also, remember to go on to Connect and complete the Learn Smart module, as well as any animation exercises and quizzes that have been assigned. Just work through the list in Blackboard. Click on each of the links. The first time through may be a little bit more confusing because we have to set up all of the different accounts so that you can take the online components of the course. Look forward to seeing you next chapter.